Here is an example of solving a somewhat complicated linear expression. This is found in Chapter 2 of your integrated textbook. I'm saying linear expression instead of linear equation or linear inequality because, like in the previous example, it doesn't matter which one. The dime on the page is hiding either the equal sign or the inequality sign. We actually don't care whether this is an equality or an inequality in terms of the steps we will go through to get a solution, which, when it's all said and done, let's see if I can do this, plan this properly. The final solution to this will read y is equal to or greater than or less than some numerical value. If it's an equality, we're looking for the one magic value of y that will make the expression true. If it's an inequality, we're looking for the set of values of y that will make the expression true. Our job is to manipulate the expression so that all the y's merge together, all the constants merge together, and ultimately the variable is isolated. Now, this particular expression has y's kind of buried in the middle on both the left and right side of the expression, so we kind of have to blow it up a little bit in order to collect the y's. It's kind of like we're excavating, and so we have to kind of blow this up and blow this up to free up the terms with y. And by that violence, I mean we're just going to multiply through those constants because we want the terms to be free to move around, and these terms are kind of locked in place with the parentheses. They're not yet free to move around. So we're going to multiply this all the way through by the 3, which will give us 6y minus 12. There's that plus 1 that's still sitting there doing nothing. Over here, we're going to multiply this out. That will give us 4y minus 6, and then the minus 8 is sitting there doing nothing. And then again, there's going to be an equals or an inequality. Not sure which, we won't know until we get rid of the coin. Simplifying a little bit here, this becomes 6y minus 12 plus 1 is minus 11. Over here, 4y, the constants combine together to become minus 14. And again, mystery symbol in between. And now what we need to do is collect the variable terms together and collect the constants together. Typically, variables go to the left and constants go to the right. And so here, I'm going to rewrite this expression, leaving a little bit of space on both sides for manipulations. And I'm going to see if I can do 2 at once, right? Because we're good at this now, so we can handle that. One thing we want to do is get the two y terms to merge into a single term with y. And so I would like this 4y term to vanish from the right side and go over here on the left side to merge with that one. Because the 4y is locked in place by a subtraction with the 14, I can either add or subtract the appropriate term to move it. So my strategy is to subtract a 4y from that right-hand side to make the 4y term vanish. Now, I am in charge of this expression, and I'm allowed to do almost anything I want to it. I have decided I would like to subtract 4y from the right-hand side, which means I then also have to do it on the left-hand side. I need to maintain the structure, the integrity of the expression. At the same time, this 11 would like to vanish from the left and move over to the right to be free to combine with the negative 14. Since the 11 is subtracted on the left-hand side, that means I would like to add an 11 to the left-hand side to get rid of it there, and that means I have to add 11 to both sides. And leave a spot for the mystery symbol. Now a little housekeeping. The 6y minus the 4y is a 2y. The minus 11 and the plus 11 is 0. Again, that's the whole point of doing the red steps here. And then here, the 4y and the 4y knock each other out. The minus 14 plus 11 gives me negative 3. So that's a lot of cleaning up there with a mystery symbol in between. And now I have 2y something negative 3. I would like to isolate the y, so I can either divide both sides by 2, or just to be a little bit different, I'll show another variety of that. I can take this 2y and I can say, gosh, it would be nice if this was multiplied by 1/2. Since I am in charge of this expression, I am perfectly welcome to multiply that left-hand side by 1/2. But I have to remember to also multiply on the right-hand side by 1/2. And then when it's all said and done, I almost planned this right, left a little bit too much space, but the 1/2 times the 2 is just y. So I have my y, and then whatever mystery symbol is there, and then this term here, it just shakes out a little bit to be minus 3/2. Okay, let's go reveal. Was this an equality or an inequality? Ah, it was an equality. Okay, so this is an equality. Equality, 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 and equality. So just to tidy it up a little bit. Oh, it's off the screen. I'm not going to be able to fix that. And I don't want to do the whole thing all over again, so I'm going to tilt the camera just a little bit. There you go. The numerical solution to that mess at the top of the page is y equals -3/2, meaning that -3/2 is the one and only magic number that, when plugged into this equation, will make a true statement.